Okay, 6S6, exponential and logarithmic equations where you have like bases. So one of the things you have to remember on this problem is that 1/2 is really the same as 2 to the negative first power. And then, so that's another way to write this 1/2 to the x plus 7. And then over on this 4, that's 2 to the second. So 4 rewritten as 2 to the second. So now I have both in base 2. The next thing is to recall that powers raised to powers are multiplied. So -1 times x plus 7 would be like negative x minus 7. And the 2 times 3x and the exponent here would be 2 to the 6x. Now when the bases, once you have the bases the same and they have these exponents, then your exponents are set equal to each other, because the only way for these two things to equal if the bases are the same is if the exponents are also the same. So finish that off. Add that x over there. I've got a 7x. And so dividing by the 7, or just logically looking at that, x would be -1. Get the bases to be the same when the bases are both numbers. So this one, I cannot change 17 into the same base as 4. Like 4 is either 4 for a base or 2. 17, there's no other options. So the way to solve this one is just converting it to a log. So log, there's your base, 4, it doesn't go in order, so now it's of the 17, and it always equals the exponent. So then it's just a calculator problem, or log base 4 of 17. If you wanted to do it, you can certainly hop into Desmos and do it. So if I, let's see if I can share my Desmos with you somewhat quickly. And just go over here. Log base 7 of 14, I think is what we had. Log base 4 of 17. Log base 4. See how that did not put it as the base? You need to put an underscore, shift in the dash, and I'll put it down in the subscript. Arrow to the right to get out of the subscript or the base. So I've got that 2.0437, etc. All right, so then back to the next problem. So how about if your exponents have the variables? So like this problem, it says just take the log of both sides. So log of 3 to the x plus 1 equals 5 to the x. Log of 3 to the x plus 1. Log of 5 to the x. The power property there would let you bring that out in front. Then after you get to that point, you could actually take these and put your x's on the same side, divide your logs to the other side. The factoring out of an x. Factor out the x on that problem. Okay, not sure what happened there. So then the next thing we could do here is just take this log times each of these, separate this all out. So I've got an x times the log of 3 plus the 1 times the log of 3 equals the x times the log of that 5. After you have those all separated out there, then the two that have this x in them, if we put those on the same side together, so like I'll leave this x log of 3, maybe let's move that to the other side actually. So if I brought this over to this side, so I've got my log of 3 equal to my x log of 5 minus my x log of 3. And then if you factor this x out, there's the factoring out that I was looking for. Now on the right, if you divide by that whole log of 3, wait a minute, log of one of those is supposed to be a 5, I think, on the right side. Okay, messed something up there. This 5 right here. So then if you divide by this to the other side, the log of 5 minus the log of 3 over to this side, so then this whole thing, if you wanted to, you could try to do your properties on that as well, but you can also just evaluate it out at this point. You know, grab a calculator and do that to solve for that problem. All right. Well, what are we going to do on this one? It's a natural log. And so if we do the inverse of the natural log on both sides, it's just going to remove it. So if we do an inverse of a natural log, that'll take those off. So then you're just solving this quadratic. I subtract that over. 16 being 8 and 2. And 2 and an 8 can make the 6 right here. So the bigger one, I want it to be negative. So when I combine them, double check that and see if that works. So negative 8x there, positive 2x, negative 8x, positive 2x. Aren't those going to make my negative 6x here? So that's good. And negative 8 times 2 is indeed there. So next part after that, set your factors equal to 0 and undo. So I get 2 solutions. Subtract 2 on both sides. This one I added the 8 to the other side. There you go. All right, so the last problem in this lesson 6-6 is if you get a real complicated logarithm problem like this one, and it's just like, you know, yeah, I could do the, bring this 5 out into the coefficient in front using the power or exponent with the coefficient rule or property. But then I'm still going to have trouble solving, but you know, we could do some things here to solve this. I mean, we could do something like dividing that 5 to the other side would give us x minus 2 over the 5. We've got the log base 10 of the 2x plus 1. At this point, try doing like 10 to the power on the other side, the x minus 2 all over 5 to equal the 2x plus 1. But this all just gets so super messy with the algebra that, as the title on this page suggests, you can also solve this problem just using, say, like a Desmos. So let me share the Desmos program with you. So I've got the log of the 2x plus 1 to the 5th power. And I'll show you one little trick you have to use with that. But the log of 2x to the quantity 2x plus 1 to the 5th, you're going to need an extra set of parentheses when you type that into a computer or a calculator, or it's going to do the wrong thing. And it's somewhat similar to, I'll just remind you of something that you're supposed to know, and whether you do or not. But if I have negative 5 to the second, what this will do if you type it in like this on a computer or a calculator, it's going to go 5 times 5, get 25, and then that negative goes on last. If that's not what you mean, if you want the whole negative 5 squared, you have to have an extra set of parentheses in there. And these logarithms work somewhat similar. I'll show you in a minute. Because if I really want the negative 5 squared, the extra parentheses so that I get negative 5 times negative 5 to be a positive 25. So what I'm about to show you, it's sort of related to that. Hopefully somebody's already emphasized with the plain exponent here. But here's what happens, and I kind of stumbled on this by accident, but when I was over in Desmos working on a problem with this, and what happened was I put in the original problem, which is what I thought it would be, the y equals the log of the quantity 2x plus 1, that quantity to the 5th. That's the way it was written in the book. And then they were looking for when it equals the y equals x minus 2. And so there should be 2 solutions, like here and right in there. If you zoom in, if you wanted to, so you could see them, there would be that one right there and this one right here. And so those would be my answers. But then when I checked it, it's like it wasn't working out. And technically, if you use your power rule on this first one, that should be the same as the y equals 5 times the log of the 2x plus 1. And when I typed that in, it's like, well, I know this one's right, this blue graph here. So there must have been a problem with the way this first one's typed in. And so this really is like taking the 2x plus 1 to the 5th and the log of that whole thing. And so if you go and you need an extra set of parentheses in here, if that's what you intend. The computer was interpreting that first way that I typed it to really be more along the lines of what I would have done. And this is actually what I typed in the first time. It's like the log of the 2x plus 1 and another log of 2x plus 1. And I did this 5 times, and then I got the graph that I had there before. And so solving sometimes just being determined to figure out, well, what is going on here? If what you want is this, I think this is 5 of them now. So that green graph right there, that is what I was doing, but that's not what I wanted. I wanted the 2x plus 1 to the 5th, not the log. This is like if you had the log to the 5th. The other thing that I found there was, I would think you should be able to type it in like this, but it does not allow it. The log, like trig functions, you can type in this way, to the 5th power of the 2x plus 1, but it will say there's an error in this expression. It does not like it that way. So again, if you do want it, the log to the 5th power, it puts that 5th power out here. So just so you know, that's what you're getting. If you want the original problem, which did look like you know, without these set of parentheses, it looked like this, but that is not what you really want. Normally, if you want that, the exponent will be here on the log. So 2x plus 1, this was the graph that they were looking for. 2x, or wait, x minus 2, my bad. X minus 2 right there. And then where these two intersect would be here and out there for your solutions. 8.2 and this negative 3.329. So I just want to make sure I shared that with you just in case for that problem with this one right here. So the log of the 2x plus 1 to the 5th, if you're going to type that in to Desmos or even a calculator, you got to have an extra set of parentheses around this. So the 5th is on just the 2x plus 1. All right, and with that, that should finish up 6.6.